All right, go ahead and move the box. All right, so today's lesson is on periodic trends, all right? And so periodic trends is going to be a lesson kind of like significant figures. There are rules you have to know that you must memorize, all right? If you don't know the rules, then it's going to be hard for you to use them. So what I'm going to do here is I'm going to point out where the rules are in your notes, but then I also need to show you why the rules are what they are, okay? So first of all, what periodic trends is dealing with, which I might need to do it this way instead, so that way I can kind of flip back and forth. What periodic trends is dealing with here is the issue of where things are located on the periodic table can tell you certain things about the element itself. So in other words, like we know based on the tour of the periodic table that we know that those elements, because they're located here, are very, very, very reactive. We know that these elements over here are not as reactive compared to these over here as compared to that column right there. We also know that this column is not reactive, all right? We know that because of where they're located. So that's kind of the same idea we're dealing with here with periodic trends, is that based on where it's located on the periodic table, we can figure out what certain elements tend to do in relation to different features about them. Okay, what we need to learn is what are the features and then what is the rule. So that's what we're taking a look at here in these notes. So the first rule we're taking a look at is this one here. Okay, so the first rule has to deal with atomic size. So find that section in your notes, atomic size. All right, and then here is the first rule. The first rule is right here. It's what's written up top in orange. That's the first rule. So this here, we'll call it this one Rule 1A, because for every topic, there are two parts. There is an A and there is a B. Okay? Rule 1A simply says this, that the atomic size, which is the size of the element, the size of the atom, it increases from top to bottom within a group. So again, a group is, we described a group as being what again? A column. Okay? Yeah, would be a wrong answer. All right? So it's a column. So that means what we're looking at here is we're looking at, on the periodic table, if we go from here downwards, all right, we know that the atom size should do what? Increase, okay? Now let me give you a reason why that's the case. So let's take a look at lithium and sodium. If I were to draw the atom model for lithium, how many rings would I draw? I'd draw two. So there's one and there's two, right? Even if I don't put the dots there, we can kind of start to see the general idea of what I'm getting across here, which is that lithium has two rings. If I drew sodium, how many rings would I draw? I'd draw three. So if I draw three rings, we can see just by looking at the rings, which one is bigger, the top or the bottom? The bottom. And why is it bigger? Because it has more rings, right? And as we were to go to sodium or potassium down here, how many rings would I draw? 4. And if I went to rubidium, it would be how many rings? So that's why you can see as we keep adding rings, the circumference, right, or the diameter, whichever way you want to look at it for the circle, gets bigger because we keep adding energy levels. That's why that's smaller, and this is the biggest of that group. But we can apply that same knowledge to every group. So again, in this column here, beryllium is the smallest, radium is the biggest. If I go over here to this side, fluorine is the smallest, acetine is the biggest. All right? If I go down a column, the size of the atom gets bigger. That's what Rule 1A is saying. Does anybody have any questions about Rule 1A? Okay, so let me ask a question real fast. All right, so let's find, I'll make it simple as possible. Those two elements right there. All right, so those two elements right there. Jacob, which one is smaller?
12. The top one.
The top one? All right, 12 is smaller, magnesium. Okay, magnesium is smaller. All right, so that's as simple as we can make Rule 1A. If it were only having to worry about what goes down a column, that would be very, very simple. Except we do have these things called periods on the periodic table, right? There are 1, 2, 3, 4, 5, 6, 7 periods on the periodic table. So because there are periods, we also have to figure, well, what is the trend in relation to size as we go across the periodic table? We know what happens as we go up and down now, but what happens as we go across? Well, if we go back to our notes, we're going to look at the next section. All right. The next section here, the rule, simply says this. The atomic size increases from right to left across a period. So that would be your 1B. Okay, that would be your rule 1B. So the rules are the headings. So hopefully you don't misplace that. All right. So the rule for atomic size is this. As you go down a group, the size gets bigger. As you go across a group from the right going to the left, your size gets bigger. All right? So that's kind of the way things look, okay? Now, the reason why the size of an atom gets bigger as you go to the left is because of this aspect. All right? So let's take lithium again. Lithium has its 2 rings, right? And it's got its 3 electrons. Who's the element to the right of lithium? Beryllium, right? If we drew beryllium, beryllium is going to be the same size in regards to rings because it's got 2 rings, correct? Mm-hmm. So what makes then the fact that beryllium is going to be smaller than lithium? Well, the reason for that has to do with attraction. Okay? Attraction is what brings things together. All right? And what do we know about attraction? Okay, apparently you don't know much about attraction, okay? Opposites attract. That's why north attracts south, okay? That's why positive will attract negative. Well, these dots represent electrons. What is the charge or the charge of an electron? Negative. What's in the center of an atom? The nucleus. What is in the nucleus? Protons. What's the charge of a proton? Positive, right? So these 3 electrons, they're attracted to the center, to the 3 protons in the middle. Here I have 4 electrons that are attracted to the center of the 4 protons, right? Well, because I have more electrons and protons, the attraction is going to be greater. So that means they're going to get compressed tighter, which is why this one will be smaller than this one, because this one has more attraction to the center than this one does, because this one has 4 negatives drawn to the center. This one has 3 negatives drawn to the center. And if we were to go to the next one, who's the next one next to beryllium? Boron. Boron has how many electrons? 5. So it's even got more electrons drawn to the center. There's more attraction. That's why beryllium is smaller than lithium, but boron is smaller than beryllium. The more electrons you have, the more attraction to the center you have. That's why size gets bigger as you go to the left, because my numbers are getting smaller, so my attraction is getting weaker. Okay? Does anybody have any questions about that? So when you look at your periodic table, because I can already tell this lesson ain't sinking through, which is only just solidifying the fact that I need to test you tomorrow then, which I'm good with. Okay? What we know about the atomic size rule is this. I know this. The rule says basically that as I go that way, size gets bigger. And as I go that way, size gets bigger. That's what I know about the periodic trend in relation to the size of the atom, also known as the size of the element.
Yeah, I understand why it gets bigger if it goes down, but I'm still having trouble understanding why it gets bigger if you go left.
Because
You said attraction to attract.
Because this thing here right here has 3 positives and 3 negatives.
Okay.
This here has 4 positives, 4 negatives. Okay? So this here, because there's more positives and more negatives, there's more attraction. Attraction means they want to get closer. So if they're closer, they take up less space. And because they take up less space, they're smaller in space than that one is.
So 3 technically will be bigger than the 4. Okay.
The 3 is bigger than the 4.
Because they're closer together.
Because the 4 is closer together than the 3s are. All right? Because remember, what attracts is opposite. Okay? Well, there's a bigger difference, right? If you're rich by $4 and you're dating somebody who's poor by $4, well, that's a bigger difference in money than somebody who is rich by $3 and somebody who's poor by $3.
Oh, yeah.
So the bigger the difference, the stronger the attraction. That's why, again, some of y'all date the stupid people that you date, because they're more different. The more different they are from you, then if you're a lady, the more you think you can help them. Well, they can't. All right, they don't want to be helped. You're just wasting your time. But you're going to use the next 30 years of your life trying to fix them. All right, but that's why they're smaller. That's why this is smaller than that one, because the attraction is greater, which means attraction means they're pulled tighter together. Where here, they're not as tight together. All right. Any other questions? Good question. Any other question about rule 1? And remember, it's got an A and a B. Okay? There are 3 rules, FYI. All right. The second rule has to do with what we call ionization energy. So look at that section there. Look at the ionization energy. And what we need to do is we need to find out what ionization energy is. So here's what we're looking at right here. This is the part we're looking at right there. Like, that's the part, if you're going to highlight them, because ionization energy is not something you heard before. Ionization energy is the amount of energy it takes to take an electron away from an element. Okay? Remember we said that sodium had only one valence electron? Right? Remember we said that because it had one valence electron, it was looking to give it up to anything? So guess what? It probably doesn't have a very high ionization energy. All right? Because it's looking to give it up. Right? So, I mean, you ain't got to work that hard when somebody's willing to give it up in the first place. So that's kind of the same idea here. Ionization energy is how much effort do you got to go through to get the electron that you want. Are we good with that? So if we look at that then, the trend here is this then. The trend for ionization energy simply says this. It says, here's your group, here's rule 2A. It says that your ionization energy increases from bottom to top within a group. Notice the wording is different than it was for 1A. For 1A, it was top to bottom. 2A is you're starting at the bottom and going to the top. Okay? So, if we look at our periodic table, let's kind of explain to you why that is the case. So again, rule 2A says that the ionization energy, as you go up, increases. So my question now is this then. So why is this one low and then this one high? That's the question that we need to kind of understand. So this is what I'm trying to explain to you. All right? So think about francium, right? If we drew francium, which we're going to draw here in a minute, but you don't got to. And my point here is, this is why this is kind of a skill. I need you to see what's going on here. You don't get it from the notes. All right? Francium, if I drew francium, has how many rings?
7.
7. All right? That's a female at the nucleus. Okay? Like, in other words, ready? Here's the girl, and here's the significant other. Got it? Man, kind of far away. You know what I'm saying? He's kind of far away from his girl. Which means he could get taken, right? Like, in other words, let's flip it. Let's say here's the guy. I don't know what I'm drawing here now, so that's supposed to be a hat. There we go. There's a hat. There's the guy, and there's the girl, right? There's a guy that I see walk the halls every day, and when he walks down the hall with his girl, he's got his arm wrapped around her. Okay? And I'm like, man, that dude ain't confident. Because he's afraid if he lets go, she gonna go away. Right? Well, guess what? If there's another guy over here, and she's way that far away from him, He ain't got to work that hard because she's already can't see him, right? He like, there's John, right? There's Joe. Joe goes up to her, says, "Hey, how you doing?" Right? She's like, "You got a boyfriend?" She's like, "Not that I can see," because they're far away. So does he got to work that hard to get her? No. Okay. However, if we drew hydrogen, right? Here's hydrogen.
Hydrogen?
Yep, the one at the top. There's hydrogen, and there's the boy, right? There's the relationship couple. There's the couple, right? Well, guess what? His arm is wrapped around her. So when a guy comes and talks to her, he's like, "She's with me," right? When she's over there in the 400 hall, he ain't ever gonna know she's talking to somebody else. So for somebody to get her, he's gonna have to work hard. For somebody to get her, he ain't got to work that hard. That's why the ionization energy for francium, there's francium, is a heck of a lot lower than it is for hydrogen. There's hydrogen. Because the gap between the couple is greater the further down you are. The further away, all right, the more likely to play. Okay? That's how it is. That's why some girls, come to school, make sure their boyfriends don't do anything stupid. And on the weekends, they get paranoid because now they can't keep an eye on them. Or vice versa. Because like I told you, the relationship I'm talking about in the hallway, that's a guy who don't let her go. I used to just whisper every time they walk by, "Let her breathe." Giovanni must know what I'm talking about because as soon as I said it, he kind of smiled and was like, "I know who it is." All right? Spanish couple, I think, too. That's probably why you know it. All right.
I thought you were talking about me.
Maybe I was. You Spanish. Never mind. We'll come. I don't want to. We're on video. Sorry. All right. So here's the rule. We know that as we go up, the energy, the ionization energy, increases. Okay. Now, I don't have to go back to my notes now. So let's go now the other rule. What's the other rule? What's 2b say? Rule 2b.
Energy,
Ionization energy
increases from left to right.
from left to right. So again, remember last time my rule said right to left. This time it says left to right. So we're going to go from here to here. The ionization energy increases. All right? It increases as you go from left to right. Remember, in other words, the way I look at it is this. The amount of effort you got to do to steal her away increases as you go up the periodic table. Don't got to work that hard, got to work really hard. But the energy that I spend to try to take her away increases even more as I go to the right. Which means I may have to work really hard to get her. Well, that's just damn near impossible. Okay? This is what you want if you're in a relationship. All right? If this is who you are, then you really ain't in a relationship. Got it? Because what you would want is security. All right? Not, I don't know what the other word would be. Okay? Trampy. All right? So, are we good right there? Notice my arrows? So the way I look at it like this is this. I'll use myself. If it's a girl that I want to bring home to mama, right? Then I'm looking over here at these. You know why? Because those are the ones that it's hard to get what you want from. The ones that I just want to see on Friday night and Saturday night, that will never even know I have a mama and a daddy. Those are those right there. Want to know why? Because those right there, as soon as I show up and say hello, I got it. Okay? That's the difference in ionization energy. How hard do you got to work to get it? How hard do you got to work to get it? Got to work really hard? Just got to show up. Okay? As I would say. Ready? This is why I'll say this. I'll put it on video. Okay? Ladies, I'm joking-ish. Most girls in Pitt County? Nor Pitt. All right? So, I know there are North Pitt girls in that area too. It's just hard to find. All right, no, just joking. So, everybody understand that rule? That's what ionization energy is. How much energy do I got to spend to get that electron? Okay? Some elements are very easy to get the electron. Some are not so easy to get the electron from. Are we good with that one? Notice up and to the right. Hard to get, easy to get. If we were doing the size of an atom, it's the exact opposite. Biggies over here, tinies over there. Because the arrows point in the opposite directions. Now, let's go to the third rule. The third rule deals with, now I got to go back, another fancy word that some of you don't get familiar with seeing every day. That rule is electronegativity. Okay? Right here. That's the definition that we need to make sure you know. So, I would say it like this. Like, if I'm using it in a way for me to understand. Okay? That's all. If ionization energy is all about the her, well then electronegativity is all about the him, through my eyes. You get what I'm saying? In other words, if I'm looking for a girl that's going to give it up easily, right, then I'm talking about ionization energy. When I'm talking about electronegativity, what I'm talking about is my ability to get girls, to attract them. All right? That's why I call electronegativity right here, that word, that's the key word you want to circle. It's the ability to attract electrons. Okay? Like, for example, there are some people, when they walk in the club, people automatically just go to them. Then there are some people, when they walk into the club, they immediately run away from them. Okay? Now, who you are, I guess, determines if you ever go to a club. All right? And you find out. But again, there are some people that just get people drawn to them. That is high electronegativity. And then there's some people that just don't want they can't attract anything to save their life. They have low electronegativity. So another way to go with electronegativity is how pretty you are, how attractive you are. All right? Because obviously, Cameron, are you drawn to ugly girls? No? Like if a fugly walked in, you're going to say, oh, hey, how you doing? My name is Cameron Jones? No, you're going to basically like look down and not make eye contact. Right? But if if a very pretty young lady walked in, he would never notice if her face was pretty. He'd be looking at something else. But then again, that's what he's attracted to. So that would be high electronegativity. Then he'd be like, hey, I'm wearing this white jacket with no shirt underneath. You into that? All right? That's what he's going to do right there. Okay? So that's what we're talking about with electronegativity. So what we want to make sure now is this. What is the rule for electronegativity? All right? Well, here we go. All in one slide right here. Here is rule 3A. Here is rule 3B. So electronegativity increases from bottom to top, just like it did for ionization energy. It increases from left going to the right, just like it did for ionization energy. So, I look at this as two simple ways, okay? You have a rule that has the arrows doing this, and then you have rules that say the arrows are doing that. All right? When I do that, I mean this. Bigger, bigger, and bigger, and bigger. Everybody see that? So you can't just say, oh, it's going to get bigger going. You got to know which one you're talking about. Because this one here has the things getting bigger as you go left and going down. This one here has things getting bigger as you go up and to the right. So the question now is, well, which one's the one that gets bigger going to the left? Which is the one that gets bigger going to the right? You have three rules. You see what I'm saying? So one's going to have one and one's going to have two. The way I remember it is simply this. The one that gets bigger going to the left is size. The ones that get bigger going up and to the right begin with the letter E. E Yes, as in energy and electronegativity. So the one for energy and the one for electronegativity, those are the ones, the E's, they increase going up and to the right. The size, they increase going left and going down. So the reason why we have to know this as a trend is because, now I'm switching screens here, so hopefully you're ready. Well, I mean, that will stay up there. That will stay up there.
What did I say?
Electronegativity. Figures you wouldn't know that. What? Well, it deals with how attractive. So, I'm sorry. It's a good thing I didn't say your name, Demetria. All right, so nobody will ever know that when they watch the video 5 years from now. All right, or worse. It'll be like 15 years from now. How old are you? That's debatable. We just had that conversation in third period too. All right. See those three that I just circled? All right. Here's my question. Don't yell out answers. My first question is this. Which one of those has the lower ionization energy? Don't say it out loud. Which one has the lower ionization energy?
Wait, which two did you say? All three?
Out of those three, which one has the lower ionization energy?
I say no. You just said don't say.
I didn't say don't answer out loud. All right. We done lost country mark. All right, so here we go. Essence question or an answer? Hold on, because I was getting ready to go to somebody who I already had on my radar. All right, Jacob, which one's got the lower ionization energy?
That one, the barium.
You can use numbers to make it easier.
56.
56 has lower ionization energy. Jonathan, you agree? I agree too.
I don't.
Okay, well, you wrong.
How?
Because energy increases as you go up and to the right, which means my high energies are higher up and more to the right. You get that? You don't get that?
Wait, so I'm wrong?
Okay. Damn. Ionization energy as you go up. Do you see that? This bigger arrow going up.
Yeah.
So
It's
where's
the lowest?
correct? So dem's bigger, dem's lower. Got it?
You want to ask me another?
Just like, ready? The biggers are over there. Right? So imagine, if you're on the right side, you're already bigger than the ones on the left side. If you're up top, you're already bigger than the ones down below. So imagine if you're to the right and to the top, then you got the most. Imagine if you're at the left and at the bottom, then you got the least, according to energy. Got it?
You want to ask me another question?
I'm going to ask about 50 tomorrow. All right? Now, same three. Same three. This question is, which of those three is greater in atomic size? Think and don't say it out loud. Which is greater in atomic size? Wesson, what you think? Same three choices, so. Huh? Oxygen. All right, Julia, agree or disagree with your friend?
Agree.
All right. Somebody tell them why they're wrong. Okay? Essence, you want to tell them why they're wrong? Don't tell me the right answer. Tell them why they're wrong.
I can because the oxygen
Okay.
so then the smaller.
Smallers. Remember, atomic size Bigger to the left. So if I'm talking JD language, that means the biggies are on the left, smallies on the right. Biggies as you go down, which means my biggies are down and my smallies are up top. So if I said which one is bigger out of the three, well, which one's more to the left? You got V and BA, right? Which one's more to the bottom? BA. That's why BA is the bigger. Okay, that's why BA is the bigger. All right. Now, let's go to electronegativity. Electronegativity. Notice this. I've asked two questions and it's been the same answer both times. All right? I mean, don't think I can't ask a third question and it'd be the same answer for the third time. Okay? So, here's my question on this one. Electronegativity. Which of those three that I've circled have the lesser electronegativity?
Lesser?
You said what?
Which one has the least electronegativity? All right, hold on. We got to hear what Country Mart says.
Barium,
Barium? Why?
because its energy level may increase it and it's very far from any of them.
It would have been a whole lot easier if you just would have said, I guessed. All right?
That's the one I said I did.
All right?
Can I say the last three?
Sure.
Because it's lower in the bottom. Right?
Isn't she wrong?
That's,
No,
he's right. Because the electronegativity increases as you go up.
Yeah.
So the higher ups have more. Highest for the least. And it increases as you go to the right. So the ones on the left have less. So if you're on the left and you're low, you got the least.
There you go.
All right. If you're high up and you're to the right, then you got the most. Okay. So out of these three right here, right? So Damien, ready? Let me ask you this question. Out of these three right up here, which one is JD?
Why you gotta put me in these?
Out of them three, which one's JD?
You might leave me alone. This is about to. Don't ask me.
Gotta answer it. Or I'm taking 30 off your test tomorrow.
Well, you just
Oxygen. All right.
What's that mean?
Yeah.
You don't know what it means? That's what he thinks. That wasn't the right answer. So, there's the right answer. All right, so oxygen is the most attractive. That's your least attractive. Now, here's my question to you. Ready? Now, here's what you got to realize. This is why you want some practice. Because how many of you were looking over here when you were trying to find that answer? Great. That ain't going to be there tomorrow. And it's not on your reference sheet. That's what your rules are supposed to know. Okay? So, here's what I would probably do for you right now is you might want to write this in your notes if you have not already done so that when you're doing your practice here in a minute, you have something you can refer to. All right? But that's the bottom line here. So, out of those three, who's the biggest? Who's the biggest? Yes. Who's the biggest out of the three?
For what?
Biggest. So, when I say biggest, I mean size.
Oxygen.
Barium is the biggest. Okay? Who's the second biggest? Vanadium. Okay? Who's the smallest out of the three? Oxygen. Get what I'm saying? So don't be surprised when you got to rank things in order. For you to rank them, you got to know. Notice, if I ask you easy question, here's an easy question. An easy question if I did this right here. If I said, essence, if I said 20 or 56, which one of those is smaller in size?
20.
Correct. That's an easy question because they're all in the same column, right? If I said 20 or 23, essence, which one of those is more attractive, higher electronegativity?
23.
23. You see what I'm saying? But where you had to do before, well, what happens here when they're not in the same row? They're not in the same column. That's what you just did. But you got to know both things. You can't just say, well, I'll just remember what it says about a column. No, because you're going to have to do these, you have to know the column and the row rules. That's what we just did. And we did one for every type. Okay? So you've done it already. Now you just got to get comfortable with it. And for Kelly, and for Lakila, that's the ending of this video.